Hello and welcome back. So in today's video and onwards, we will be solving some sequences and patterns questions from past papers for O levels and IGCSE. So let us start it. So here we have questions of sequences and patterns from the O level past papers. And you can see the year of past paper over here. It is a question from June 2023, paper 1, variant 2, and it is question number 13 of that paper. The A part of the question states these are first four terms of the sequence 1, 3, 9, 27. Find the next term of the sequence. And in order to find the next term of a sequence, we first figure out the term to term rule for that sequence. As we can see, the numbers are 1, 3, 9, 27. So we are clearly multiplying it with the 3. So the term after 27 will be 27 times 3, and that becomes 81. So 81 is the fifth term of that sequence. The B part states these are first five terms of a different sequence 35, 31, 27, 23, and 19. Find an expression in terms of n for the nth term of this sequence. So we are to figure out the nth term of this sequence. So first we will figure out the type of this sequence. As we can see, the sequence terms are 35, 31, 27, 23, and 19. We can see that like it is not an exponential sequence because the terms are not generated by multiplying or dividing. So we will start the finding the difference sequence. 31 minus 35 is minus 4. 21 minus 31 is again minus 4, and same is the difference of next consecutive terms. So as the first difference sequence is a constant sequence, so it is a linear sequence. And in case of a linear sequence, the nth term formula is a plus d times n minus 1, where d is the common difference, which is 4 over here, and a is the first term of the sequence. So we will replace these values 35 plus d, but d is minus 4, so it will be minus 4 times n minus 1, and when we simplify it, it becomes 35 minus 4n plus 4, so that becomes 39 minus 4n. So that is the nth term of this sequence. So let us move to the previous question. It is a question from June 2023, paper 1, variant 1, and that is question number 15. It states these are the first four terms of a sequence 1, 7, 13, 19. Find an expression in n for the nth term of sequence. So as we can see, the terms are 1, 7, 13, and 19. And if we observe the term to term rule, the terms are not generated by multiplying something. So we will first figure out the difference of this sequence. 7 minus 1 is 6. 13 minus 7 is 6, and same is the difference of 19 and 13. So it is clearly a linear sequence again, where the common difference d is 6, while first term of this sequence is 1. So as we know, the nth term formula will be a plus d times n minus 1. So it shall become 1 plus 6 times n minus 1, and when we will simplify it shall become 6n minus 5. So that is the nth term formula for this sequence. Let us move to the previous question. It states the 30th question. It states the nth term of a sequence is 3n square minus 1. We can see it is a quadratic expression, so the sequence is talking about is a quadratic sequence. Find the first three terms of the sequence, and in order to figure out the first three terms, we will replace n with 1, 2, and 3 respectively, and that will generate us the terms of the sequence. So when we replace n with 1, it shall become 3 times 1 square minus 1. When we replace n with 2, it will be 3 times 2 square minus 1, and when we replace with 3, it shall become 3 times 3 square minus 1. So after simplifying, we will get 2, because 1 square is 1, 1 times 3 is 3 minus 1, it is 2. Then it is 2 square, which is 4, 4 times 3 is 12, and when we subtract 1, it is 11. The term after that shall be 3 square is 9, 9 times 3 is 27, minus 1 is 26. So these are the first three terms of a sequence given, which was a quadratic sequence. Now in B part it states these are the first five terms of a different sequence. They are 1, 3, 9, 27, 81. Find an expression in n for the nth term of sequence. So as we can clearly see, we have seen this question previous in the previously it was 1, 3, 9, 27, 81. As we see, we get the next term by multiplying it with the number. So it is a geometric or an exponential sequence. And in case of exponential sequence, the nth term formula, as we have to figure out the nth term of this sequence, nth term formula is a multiplied to r to the power n minus 1, where r is the common ratio, which is 3 over here. Like 3 divided by 1 is 3, 9 divided by 3 is 3, 27 divided by 9 is 3, and same is the ratio of 81 and 27. So r is 3, while a is the first term, which is 1 over here. So the nth term formula for this sequence shall become 1 multiplied to 3 to the power n minus 1, and that is clearly 3 to the power n minus 1, because it is multiplied to 1, which do not change anything. So nth term formula for this sequence is 3 raised to the power n minus 1. And we have discussed this question before, like when we discussed the exponential sequence. Now here is the question from another paper, and that is an important question. It states Shani makes a sequence of patterns using counters. Like we can see the pattern 1, then pattern 2, and pattern 3. So it states complete the table where there is a pattern number and then there is number of counters. We can see the total number of counters in first pattern are 5, then the next pattern they make up 8 and then 11, and we can see this in the table as well. 5 plus 3 it is 8, 8 plus 3 it is 11. So the term after that shall be 14, and the term after that will be 17. So that was the A part. B part states find an expression in n for the number of counters in pattern n. As we see, it is a linear sequence because we are continuously adding 3 to each term, and the nth term formula for it shall become 5 plus 3 times n minus 1, because we know 5 was the first term of the sequence and 3 was the common difference. And when we simplify, it shall become 3n plus 2. So that is the B part, and it is worth 2 marks and very easy. C part states this part is important. It say Shani has 100 counters. She uses some of the counters to make pattern 20. She uses all the remaining counters to make pattern K. Find the value of K. So as she used like uh, some counters to make pattern number 20. So first we will figure out that how many counters she has used in pattern 20, and for that we will replace n with 20. So it shall become 3 times 20 plus 2, and that shall become 62. So she has used 62 counters in making pattern 20. So remaining are 100 minus 62, which are 38. So she is left with 38 counters to make the pattern K, and we have to find the value of pattern K, value of K, and we know uh, if it is a pattern K, it will 3K plus 2, and that equals 38. And for that we will uh, first move 2 to the right hand side. 38 minus 2 shall become 36. So K shall become 12. She can make two patterns, pattern 20 and pattern 12 from these 100 counters. So these were a few questions from the past paper for O levels. We will be solving some other questions from O levels and then we will move to the IGCSE questions.